All right, let's try this. First problem I'm going to do is 20-10, and it's a series resonant circuit problem. Take a look at it there. Design a series resonant circuit to have a bandwidth of 400 hertz, using a coil with a Q, and this is Q for the coil, of 20. So that would be Q with a little l there, of 20, and the resistance of 2 ohms. Okay, so series resonant circuit, so that's what I've drawn here. Not quite as nice as you might see on a whiteboard, but you do have the resistor, the inductor, and the capacitor there, and the source. So what we're looking at, we have just so we're clear here. Let's look at. Oops, let me get this thing on marking. Try this. All right, so we've got something that looks like this, and we're talking about, a bandwidth of 400 hertz. So that's from here to here. This is our F1. This is our F2. Okay, and we're looking for the capacitance of the capacitor, the inductance of the inductor, and we're looking for F1 and F2 here. So, what are we going to do first? Let's see here. I was thinking I could slide this up. I don't know why. All right, here, let's see. All right, I'm going to move this up. All right, so what we have, so first of all, let's remember that the Q of the series circuit, and this is really the Q of L, which we said was 20 in this case, okay? So knowing that, we can say QL equals the reactance of the inductance over R. All right, so we can solve for the reactance of the inductance, and that will be the Q of the inductor multiplied by the resistance, which is 20 multiplied by 2 ohms. So we have 40 ohms for the reactance. Now, since we know this is in resonance, then we know that the reactance of the capacitor is equal to the reactance of the inductor. So that is also all 40 ohms. All right, what else? So we wanted to find, or we actually know the bandwidth, but we want to find F1 and F2. So F1 and F2 associated with the bandwidth. Well, we have the bandwidth equal to the resonant frequency over the Q factor. Okay. Let's see, were we given the resonant frequency here? No, we weren't given resonance frequency, but actually we're going to solve for that, right? We're going to solve for the resonant frequency because we know the bandwidth. The bandwidth multiplied by the Q. All right, so we're going to have 400 times, what was it, 20. So that is 8 kilohertz. Kilohertz. Let me see if I can. Kilohertz. All right, so move that up a little bit. We were still looking for F1 and F2. So we know, and I didn't draw this on here, but we know this point right here now. Oops. We know that point right there is 8K hertz. Okay, so we're looking to get F1 and F2. So F1 and F2. we have for F, oops, right, so for F2, if we recall, we have, once we know the resonant frequency, Fs, it's going to be that plus the bandwidth, or half of the bandwidth, right, which is 8K plus 400 over 2, which we end up with 8.2 kilohertz. All right, and then the other way, F1, and the way I defined them, would be the resonant frequency plus half of the bandwidth again. Oops, boop, 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 boop. Let's back that up. I'm just copying that formula, and that's not what I want. I want to subtract the half the bandwidth, right? So again, it's going to be 8K minus 400 over 2, which ends up being 7.8 kilohertz. So I'm zipping through this, and it's being recorded. Hopefully, as you go through this, you can stop it at any point and record whatever I got, or ask questions, talk it over with somebody. But I'm going to rattle through this and try to make it as brief as possible, assuming that you're going to stop it at times to think it over, to mull it over, to make sure I'm doing it right. And if necessary, do it off on your own and verify what I'm doing to make sure you're comfortable with what's going on here. All right. And we need to determine, the last thing we need to determine was the reactance, no, excuse me, not the reactance, we need to determine the inductance of the capacitance, right? So let's do we have the reactance of the inductor, 2 pi f L, right? So we know everything in here except for the inductance. So we'll solve for the inductance, and we'll have the reactance divided by 2 pi f, which the reactance was 40. We solved that earlier. Let me just verify that here. 40, 40, 40, 40. Yes, we did. 40. Divide by 2 pi. Now, F in this case is going to be the resonant frequency. Okay, we said the thing's operating at resonance. We solve for resonant frequency, and we determine that to be 8K, right? Yes, 8K. 8K. So we go ahead and multiply that out, divide it out, and we come up with 795.8. I'm going to write this underneath here. Hold on, I can slide it, I think. Microhenries. Okay, so that's that. Let's see, there we go, I can shrink that a little bit too. All right, so let's go ahead and solve for the capacitance now. So the capacitance for this guy is going to be, well, not the capacitance. Let's first go through boop, 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 and we want to determine the capacitance, but what we have is the reactance of the capacitor, right? So that is actually 2 pi f C. All right, and then we're going to go ahead and solve for C. So we'll have C equals 1 over 2 pi f, and that's multiplied by the reactance. Okay, so I'm going to just keep going this way. Oops, oop, 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 oop. Go and try that one more time. I haven't used this a ton, and I actually haven't used it at all this year, but I thought it would be a good way to get this across since my other method wasn't really working out. Anyways, so we're going to go ahead and plug the values in here. So we have 2 pi, and the resonant frequency was 8K, and the reactance was the same as the reactance for the inductor, so that was 40. And when I got to remember to change that when I do that. When we multiply this all out, divide it out, we get 497.4 nanofarads. All right. So I think that was the last piece. So if we look at what we started with that circuit there, we were given we were given the Q factor, we were given the internal resistance, and the bandwidth. We went through and we solved for both inductor capacitance, the inductor, the inductance, the capacitance, and F1 and F2. So that should do it for that one.